Hello, my dear student. Today we are going to continue our discussion on the first transition series. We are going to discuss the iron and different types of ores that iron exists in them, and we are going to discuss their molecular formula, and we are going to discuss how can we extract the iron from its ores, and we are going to discuss the concept of alloys and different types of alloys of iron, and we are going to discuss their properties. So let us start. Iron as element has atomic number 26 and atomic mass 56. The iron is found in the form of ores, as it is found in elementary state only in meteorites by 90%. Iron is the fourth most common element in the Earth's crust after oxygen, silicon, and aluminum. So its arrangement is the fourth element. It forms 6.3% of the weight of the Earth's crust, and its amount increases near the center of the Earth. The suitability of the ore for extraction of iron economically depends on the iron percentage in the ore, the composition of the impurities in the ore, the type of harmful elements mixed with the ore, for example, sulfur, phosphorus, and arsenic. The important types of ores. As shown on the screen, the ore and the molecular formula and the color and the percent of iron and the property and the occurrence. The first type of ore is called magnetite. Has molecular formula Fe3O4. We can name it magnetic iron oxide or black iron oxide. Its color is black, and the percentage of iron ranges from 45 till 70%, and its magnetic property, and is found in the eastern desert. Hematite, its molecular formula Fe2O3 or iron 3 oxide. Its color is blood red, and the percentage of iron is from 50 till 60% and easily reduced, and it is found in oasis area. Limonite has molecular formula 2Fe2O3.3H2O. Its yellow color, and the percentage of iron ranges from 20 till 60%, and it is easily reduced, and it is found in oasis area. Siderite has molecular formula FeCO3 or its chemical name iron 2 carbonate. My dear student, you have to keep the chemical name of each type of ore: magnetite, magnetic iron oxide; hematite, iron 3 oxide; limonite, hydrated iron 3 oxide; siderite, iron 2 carbonate. Siderite has yellowish gray color and the percent of iron 30 till 42% and easily reduced, and is not found in Egypt. The extraction of iron. The extraction of iron passes through main process: ore dressing, reduction of the ore, and steel production. We are going to discuss them in details. First one, we are going to discuss ore dressing. The ore dressing aims to what? Aims to improve the physical and mechanical properties of the ore and improve the chemical properties of the ore. This occurs by 4 processes. 3 processes for improving the physical and the mechanical properties, which are crushing, sintering, and concentration process, and 1 process for improving the chemical property of the ore, which is called roasting. We are going to discuss them in details. Crushing process. It is the breakdown of the ore to obtain suitable small size to be easily reduced. As shown on the screen, here the cracking of iron ore into suitable small size particles to be easily reduced. The next process, which is sintering process, it is the treatment or collecting of fine particles of the ore that resulted from the crushing and the cleaning of the furnace to obtain similar and homogeneous larger particles. The third process is concentration. It is increasing the percentage of iron in the ore by removing the unwanted impurities that are combined or mixed with the ore through using the surface tension property as the following animation show. As shown on the screen, the iron ore is put through water and oil such that the oil is mixed with the ore and the sand and other impurities at the bottom, and so we can separate the ore from the iron and the sand, so we can get the ore without the sand or other impurities. The next property is the magnetic or electric separation, that shown in the following animation. As shown on the screen, by passing the ore over magnet, so the iron ore is attracted to the magnet while the sand and other impurities are repelled from it, so we can separate the iron ore from the impurities. The fourth process for ore dressing is roasting process. It is heating the ore strongly in air, and we have given reason for this point. This is done due to drying the ore to get rid of humidity and converting the ore into iron 3 oxide, which increases the percentage of iron, such that iron in iron 2 carbonate has 48.5%. On heating in the iron 2 carbonate, it gives carbon dioxide and iron 2 oxide. As we know that iron 2 oxide is easily oxidized by air into iron 3 oxide, which has a percentage of iron 69.6%. So we have increased the percentage of iron on converting iron 2 carbonate into iron 3 oxide. So my dear student, we have a question in this point: how to obtain iron 3 oxide from iron 2 carbonate. You have to write these two equations, or we can say how to obtain hematite from siderite. So my dear student, you have to write these two steps of the reactions to obtain iron 3 oxide from iron 2 carbonate. And if we use limonite, which is hydrated iron 3 oxide, as shown on the screen, 2Fe2O3.3H2O, by heating, the percentage of iron has increased when it converted into iron 3 oxide. The percentage of iron from 40% has increased to 69.6%. So we can ask about how to obtain hematite from limonite. You have to write this equation. And while this process happens, oxidation of some impurities occurs. For example, sulfur combined with oxygen forming sulfur dioxide gas, and phosphorus combined with oxygen forming phosphorus pentoxide gas. Now we are going to discuss the second stage for the extraction of iron, which is the reduction of iron ore. The reduction of iron ore occurs by two types of furnaces. Blast furnace that reduces the iron ore by carbon monoxide gas, which is obtained from coke. The second type of furnace that reduces the iron ore is matrix furnace, which use carbon monoxide and the hydrogen gas that we call water gas can be obtained from natural gas to reduce the iron oxide, which is hematite, into iron. So my dear student, we have two ways to reduce the iron 3 oxide or hematite by blast furnace or matrix furnace. The reducing agent in blast furnace is carbon monoxide, while the reducing agent in matrix furnace is mixture of carbon monoxide and the hydrogen gas that we call water gas. My dear student, we obtain the carbon monoxide gas in blast furnace from coke, but we obtain the water gas in matrix furnace from natural gas, and we are going to discuss this in details. We are going to discuss the blast furnace first. As shown on the screen, this is the blast furnace that the reduction process takes place by carbon monoxide gas. As coke forms reducing agent, which is carbon monoxide for the iron ore. And this is done as the following animation show. My dear student, here the iron ore and the coke are dropped down from the top of the furnace, and then by pushing the hot air inside the furnace in order to complete the formation of the reducing agent, which is carbon monoxide, then carbon monoxide will reduce the iron ore into iron, and slag here is formed to remove the impurities, and we obtain the molten iron at the bottom of the furnace. So, my dear student, the coke, which forms the reducing agent from iron ore, has the following steps: carbon plus oxygen, that by heating gives carbon dioxide gas, and then carbon dioxide gas reacts with carbon and reduces it into carbon monoxide gas, as the following animation show. As shown screen, my dear student, here, when dropping the iron ore and the coke from the top of the furnace, here the carbon combine with oxygen gas, forming carbon dioxide gas, and then carbon dioxide gas reduces the coke into carbon monoxide, that reduces the iron 3 oxide into iron, and we can collect the iron at the bottom of the furnace as shown on the screen. So my dear student, the carbon monoxide reduces the iron 3 oxide into iron as the following equation proceed. Iron 3 oxide plus carbon monoxide by heating gives iron and releases carbon dioxide gas. The second type of furnace that reduces the iron ore into iron is the matrix furnace. As shown on the screen, the reduction by mixture of carbon monoxide and the hydrogen, which is called water gas, resulted from the natural gas, which is methane gas 93%. As the animation shows here, the formation of the water gas is happen in cycle that the methane gas or natural gas combine with carbon dioxide and water, forming the carbon monoxide and the hydrogen gas that can be used for reduction for the hematite into iron, and we collect the iron at the bottom of the furnace. So, my dear student, here the equation of formation of water gas as shown on the screen, methane plus carbon dioxide plus water by heating gives carbon monoxide and hydrogen gas. So we form the reducing mixture for hematite. Then iron 3 oxide is reduced by this mixture, carbon monoxide and the hydrogen, forming iron, and releases carbon dioxide gas and water vapor that can be used for production of another amount of water gas. Now we are going to discuss the third step, which is the steel production, which depends on removal of impurities in iron from reducing gases and addition of desired elements to iron, giving steel required properties. My dear students, we are going to discuss the types of furnace that produce steel. But first, we know that different types of iron, such as cast iron and steel, can be obtained from different types of furnace, which are oxygen converter and open hearth furnace and electric furnace. My dear students, to know how can you extract the iron from its ore, it must be passed by 3 stages. The first stage is to improve the physical and the chemical properties of the ore by using the process of crushing, concentration, roasting, and then we can reduce the iron ore into iron by blast furnace or matrix furnace. Then we can make the steel to be used in different industries by using types of furnaces called oxygen converter, open hearth furnace, electric furnace. Now, my dear students, we are going to discuss the different types of alloys. What do we mean by alloy? Alloy is formed when 2 or more metals are mixed together, as iron and chromium, or iron and manganese, or iron and nickel. Also, it may be formed when metal is mixed with other non-metal, such as carbon. The preparation of alloys: by melting metal, then mixing them together with the desired ratio and leaving them to cool gradually, or by electrode deposition. The electrode deposition of 2 metals or more at the same time using electrolytic cell with the object to be plated as the cathode, and the electrolyte is the salt of solution of the metals as in press by placing zinc and copper in salt solution together. For example, my dear student, is the electroplating of iron handles with brass, which is alloy made of copper and zinc. Now we are going to discuss the types of alloys in details. The first type of alloy is the interstitial alloy. The second type is called substitutional alloy, and the third one is called intermetallic alloy. The interstitial alloy, we are going to discuss it in details. This type of alloys is formed when new atoms are introduced in the spaces between the metal atoms in the crystal lattice, and due to their small size causing the change in the physical properties of the metal, such as malleability, ductility, and melting point, or electric conductivity, or magnetic property, and the strength of the alloy, it will be harder than the pure metal. The example for interstitial alloy is iron-carbon alloy, which is called steel. The second type of alloy is substitutional alloy. It is formed when the introduced atoms replace some of the metal atoms in the crystal lattice shape. And this occurs when the introduced atoms have the following conditions: nearly the same diameter, same chemical properties, and same crystal lattice structure. The third type of the alloys is called intermetallic alloy. They are formed when the elements forming the alloy combine with each other to form chemical compounds with new properties. Here, the formula of the formed compound disobeys the law of valence, and the formed compounds are solids and they cannot be formed from the metals of the same group. For example, nickel aluminum alloy and the copper aluminum alloy that called duralumin, and lead gold alloy that has chemical formula Au2Pp, and cementite alloy that has chemical formula Fe3C. Now, my dear students, we have some questions on this part. The first type of question is to choose the correct answer. All the following compounds are iron ores except what? Magnetite, limonite, dolomite, hematite. If you think about it, yes, it will be dolomite. My dear student, you have to remember magnetite has chemical formula Fe3O4, limonite 2Fe2O3.3H2O, hematite Fe2O3. Next point. Iron is found in free state in what? Siderite, meteorites, Earth's crust rocks, alumina. If you think about it, yes, it will be meteorites. Next point. On heating iron 3 oxide in the presence of mixture of carbon monoxide and the hydrogen gas, it is reduced to what? Iron 2 oxide, magnetic iron oxide, iron, mixture of iron 2 and iron 3 oxide. If you think about it, yes, it will be iron. Next point. On heating iron 3 oxide with carbon monoxide gas, it is reduced to what? Iron 2 oxide, magnetic iron oxide, iron, mixture of iron 2 and iron 3 oxide. If you think about it, yes, it will be iron. Next point. Furnaces that reduce the iron ore by water gas is what? Is it blast furnace, matrix furnace, electric furnace, oxygen converter? If you think about it, yes, it will be matrix furnace. Next point. Furnace that reduce iron by carbon monoxide gas is what? Is it matrix furnace, blast furnace, electric furnace, oxygen converter? Yes, it will be blast furnace. Next point. The iron produced from the oxygen converter is what? Cast iron, steel, big iron, A and B. If you think about it, yes, it will be A and B. Next point. Heating iron ore strongly in air, that's called roasting, to convert it to what? Iron 3 oxide, iron 2 sulfate, iron 2 carbonate, iron 2 sulfide. If you think about it, yes, it will be iron 3 oxide. Next point. Siderite ore is what? Is it iron 2 hydrated? Is it iron 2 oxide? Is it iron 2 carbonate? Is it iron 3 oxide? If you think about it, yes, it will be iron 2 carbonate. My dear students, we have reached to the end of our program today. I hope you understood all the points that we discussed today. So till we meet again, my best wishes for you.